Hi, Assalamualaikum. It's me, Anis Humaira.
Hi, I'm Chantong.
Hi, my name is Muhammad Aikabi Osman.
So, hi, Assalamualaikum. My name is Sadina Mira.
I'm Dora.
Okay, hi everyone, I'm Dora. We are from group 9 and today we are going to present the solutions for question 13.17. So ethylene is produced by dehydrogenation of ethane as shown in the balance equation below. If the feed includes 0.5 mole of steam and inert diluents per mole of ethane, so we set the basis 1 mole of ethane feed and 0.5 mole of steam. If the reaction reaches equilibrium at 1100 Kelvin and pressure 1 bar, what is the composition of the product gas on the water-free basis? So we have N naught equal to 1.5 mole, which is the initial amount number of mole, 1 mole of ethane with 0.5 mole of steam, and we have the stoichiometric coefficient equal to 1, which is 1 H2 plus 1 C2H4 minus 1 reactant, which is C2H6 ethane. So this is the diagram of the process. To solve this question, first we have to calculate for the reaction coordinate or the epsilon of the conditions given, meaning that we have to generate these equations from this formula with the N naught equal to 1.5 mole, which is 1 mole of ethane plus 0.5 mole of water. Okay, at the end of the question, we are required to calculate the composition of the product gas on a water-free basis, meaning that the N naught will be 1 because 0.5 mole of water will be deducted from 1.5 mole. But we cannot directly calculate the composition of the product gas with N naught equal to 1 because the equation, the reaction given is with 0.5 mole of water. Even though the water does not take part in the reaction, but it does increase the number of mole initial by 0.5 mole. So meaning that the epsilon must be calculated from this equation with N naught equal to 1.5 as given in the conditions. So to calculate epsilon, we have to substitute all these equations into this formula, but we'll get another formula with an unknown k. And to solve for k, we can use this formula, but we still need to find delta G. So Chantong will be explaining how to obtain this.
Okay, finding of del G. Today I'm going to present finding of del G. So before get into the calculation for del G, let's summarize the data and information we have right now. So from previous, we have this chemical equation for the reaction, and we know that the reaction is take place at 1100 Kelvin with the pressure of 1 bar. To find del G, we use this chemical equation. and I will name the first integration as CP1 and the second integration as CP2. So according to the formula here, we will need to find standard del H, standard del G, CP1 and CP2. Standard del H and standard del G is the value of del H and del G at standard condition, which is 25 degrees Celsius or 298.15 Kelvin, and this R is the standard constant value. So now let's find standard del H and standard del G. To find standard del H and standard del G, we will use the table C4 in our reference book, in the appendix of our reference book. So this is the table C4 in our reference book, and let's see our chemical equation here. Okay. The reactant is ethane and the product is hydrogen and ethylene. So in this case, hydrogen is not taken into consideration because the value of standard del H and standard del G for hydrogen is 0. So ethane and ethylene, the value is highlighted as shown in the PPT. Now let's calculate the standard del H and standard del G for the reaction. To calculate standard del H or standard del G for the equation, we will take the standard del H of the product minus standard del H of the reactant. Same go to standard del G. So standard del H of the product ethylene is 52510 minus negative 83820. So we will get 136330. Same go to standard del G, which is the standard Gibbs energy. We will get 100315. So we already find the standard enthalpy and the standard Gibbs energy for the reaction. Now we need to find CP1, the first integration, and CP2, the second integration. To find the first integration, CP1, we will use the equation shown here, equation 4.19. You can find it in our reference book. So to calculate CP1, we need the value of tau, del A, del B, del C, and del D. So to the tau value is T divided by standard T. T divided by standard T, you will get 3.6894. And the del A, del B, del C, and del D can be obtained from our reference book. So from table C.1 in the appendix of our reference book, we will have the value of del A, del B, del C, and del D. So let's refer back to the equation we have for this reaction. The reactant is ethane, the product is hydrogen and ethylene, as mentioned previously. So let's highlight the value of these three chemical species. We will have the respective A, B, and C, and the value and calculation is listed in this table. So finally we will get the final answer for del A, del B, del C, and del D. So we already find every unknown in this equation, so we will substitute everything into this equation. So by applying basic maths technique and maths skill, we will get CP1 equal to 897.285. So we already find CP1. Next we're going to find CP2. To find CP2, we will use this equation and equation 13.19. So in equation 13.19, we need the value of tau, del A, del B, del C, and del D, which we already calculated in CP1. So the calculation and the value from CP1, we just strictly take the answer lah. So from the previous calculated value, we can get all the requires unknown in this equation. So by substituting everything into this equation, we will have CP2 equal to 1.7872. So finally, now let's find del G for this equation, for this reaction. So substitute every given data and value into the equation, into the formula stated here. You will get del G. So let's substitute everything. By substituting everything into this equation, we will have del G equal to negative 5428.62.
Now we will calculate the value of equilibrium constant K. By using these equations, relations of equilibrium constant to composition, we know that in order to get the compositions of each species in these questions, we need to find the equilibrium constant K value. So, from 13.11a, we know that the K is equal to exponent negative delta G over RT. From previous calculation, we know that delta G is equal to negative 5428.62 joule per mole. So by taking the value of R 8.314 joule per mole K and temperature is 1100 Kelvin, by substitute all the value into this equation, we can get the value of K, which is 1.8105.
Okay guys, for the next step is to calculate the reaction coordinate. Okay, from the previous explanation from Dora, we get that the total stoichiometry for the whole system is positive 1, and from the mole that came into the system is 1.5 mole. Okay, so the other part to find the reaction coordinate is we must know all the mole fraction formula for each species. Okay, same for with Dora, we find that a mole fraction of ethane, which is this, and mole fraction of hydrogen gas, which is this, and lastly the mole fraction of ethylene, which is this. Okay, so we move to the next slide. Okay guys, for next part is to find reaction coordinate, we must use equation 13.28. Okay, which is it has mole fractions of species, power of their own stoichiometry, and multiply with each other, equal to pressure on the system, which is 1 atm, and divide by pressure standard, which is 1 atm also. Okay, and power of negative 1 times by the total stoichiometry, and multiply also them by K. After that, we substitute all the equations and equal to K. Okay, for the ethane we get negative 1 because it is a reactant, of course, and the other two is positive 1 because of it is a product for the system. And after we simplify, we get this kind of equation. Okay, from the previous calculation by our members, we get that K is 1.8105. After that, we substitute K to this equation. Okay, after that, we must guess the first value of the reaction coordinate. So we decide together that we use 0.6 for the first guess. You can put any values, it doesn't matter. After that, we use calculator to find the actual value for reaction coordinate using the shift solve formula or method using calculator, and we get the reaction coordinate for this problem. We get 0.83505. So that's all for me. We can move to the next member. Thank you.
Okay, so next we going to calculate the composition of the gas product on a water-free basis, which is without the steam. So from the previous slide, V is equal to 1, still same in this slide, but not for the mole in. So the mole in is equal to 1.0 mole of ethane. So in this slide, you do not need to add 0.5 mole of steam since the equation is on a water-free basis. So now you have new NO, which is 1.0 mole. So next we will calculate the mole fraction for each species using the equation 13.5. So as you can see, the equation is still the same as the previous one, but you need to replace the NO value. So from the previous one, the NO value is 1.5 because it includes the steam. But in this part, you need to use the new NO, which is 1.0 mole. So just replace the NO value with new mole without the steam. So this is your new equation. So we will move to the next slide. So in the next slide, what you need to do is just substitute the reaction coordinate E value into the equation. Then by using your calculator, you will get the final answer, which is the mole fraction calculation for each species. Okay, that's all from group 9. Thank you for watching. Good luck. Assalamualaikum.